Hello everyone, welcome back to my channel Electrical Concepts. My name is Avigan Roy. So in this video lecture, I'll be discussing about DC transient behavior of capacitor. In my previous video lecture, I have discussed about the DC transient behavior of inductor. So let's start with initial and final value theorem, which I already discussed in my previous video lecture. So if you haven't yet watched that previous video, then please first go through that video, then come back to this video. All right. So this is the initial value theorem, as we have already discussed in my previous video lecture. So xt is the function in time domain. So t tends to 0, limit for the function xt is equal to limit s tends to infinite sxx, where s is the frequency domain, and based on the Laplace transform, s is equal to j omega. So based on this fact, we can say omega is also tending towards infinity when s tends to infinite. That is why xc, that means the capacitive reactance, is tending towards 0 at the initial condition. What does that mean? It means capacitor behaves as short circuit at initial condition. Why? Because capacitive reactance is 0. That means it is behaving as a short circuited path, right? So now let's see what happens in final value theorem. I mean at the steady state condition, that means t tends to infinite. So here if you apply the same concept, you will get to see x is tending towards infinite. What does that mean? It means the capacitor behaves as open circuit at steady state condition. Why? Because it is providing infinite capacitive reactance. That means no current can flow. What does that mean? It is open circuit. Alright. And this entire analysis is based on the fact that the capacitor doesn't have any initial voltage across it. So there is no initial voltage or previous value of voltage present across the capacitor. Okay, so now let's see what will happen when the previous voltage is present across the capacitor. So this is the question: what will be the transient behavior in presence of initial voltage? So just consider this is the circuit, RC series circuit, and initially this V0 is the previous value of voltage, initial value of voltage across capacitor, and suddenly this supply voltage has come into the picture. So now what will be the transient behavior? That is the point of discussion. Okay, so using KVL we can write Vs is equal to RIC plus 1 by C integration of IC dt, where IC is the current flowing in this circuit. Okay, so if you perform the Laplace transform, you will get to see this will be the expression of the Laplace transform of the current flowing through the capacitor ICS. Okay, and V0 is the initial value of the voltage that is already present across capacitor, which I just told. So this is the Laplace transform of the current through the capacitor. So if you further notice, we also know the voltage across capacitor can be written as 1 by C integration IC dt. So from here, if you replace this ICS by this value, then you will find this expression of VCS, that means the Laplace transform of the voltage across capacitor. So now if you apply the initial value theorem on this expression, see limit s tends to infinite s VCS, you will get to see the initial value of the voltage across capacitor is nothing but V0, which is this, the previous value of voltage. What does that mean? It means the previous value of the voltage across the capacitor will still be there even after the change in the circuit. Okay, for a certain period of time. So what we can say, capacitor maintains its previous value of voltage at the initial stage. So V0 is the previous value of voltage which was already there across capacitor. Now suddenly there's a change in the circuit takes place and this supply voltage has appeared, but still that capacitor maintains that previous value of voltage even after the change in the circuit. So that is called the electrical inertia. Okay, inertia means something which is retained. Okay, so here the voltage capacitor is retaining that voltage even after the change in the circuit. Okay, so that is where it is called electrical inertia, and as because it is holding that voltage, that previous value of voltage even after the change in the circuit, we can say initially it also behaves as a voltage source, right? So I think now this entire thing is clear to you, that why does the capacitor behave as open circuit at the steady state condition and the short circuit at the initial condition. Why does it even behave as voltage source in presence of initial voltage? What is electrical inertia? Okay, so this entire analysis, I guess it is clear to you. Okay, so if you have liked this video, please share, comment, and also don't forget to subscribe to my channel. And in my next video lecture, I will come up with some more interesting topics related to this. Till then, goodbye and thank you so much.